Hey guys, this is Rishendra. So today we'll continue with the large language models topic. So today we'll start with the temperature, top K and top P. So these are like the parameter controls. So uh, these parameters control like how creative or predictable and large language model response is. So temperature controls the randomness in generated responses. So the range is from like 0, which means very predictable, and more than 0, which means the more numbers it gains, the more creative it is. So if it is like one or two, three, four, five, so the more the number is, the more creative the large language model is. So next is low temperature. So low temperature, like for example, if the temperature is equal to like 0.1, so the output will come out like the earth revolves around the sun. So this is used for like coding, mathematics, and technical answers. So next is the high temperature. So in high temperature, like for example, if the temperature is like 0.9 and the output comes like the earth dances around the sun in a cosmic journey. So in a range of like 0 to 1 or more. So the more creative the number, the higher the number, the more creative the output. And the high temperature is mainly used in like creative writing or maybe like brainstorming. And so it is used to create more creative answers. The next is top K sampling. So top K limits the model to selecting from the K most likely next tokens. So for example, if a top K is equal to 5, the model only considers like 5 probability words instead of all the possible words. So, for example, the possible, uh, so for example, if we take like a top K is equal to 5, the possible words would be like Paris with a probability of 40%, Tokyo with a probability of 5%. So, and London with a probability of 20%. So, there are options, and if like the top K is equal to 3, then only Paris, London, Rome. So like those are considered. Next is top P sampling. So top P sampling is also known as nucleus sampling. So top P selects tokens whose combined probability reaches a specific value. So, for example, if a top P is equal to 0.9, so the model chooses words until it reaches the 90% probability coverage. So, the differences between the top P and top K sampling are like, so the top K sampling has like fixed number of choices. So, for example, it's like always choose the top 10 words. And the top P sampling has like dynamic number of choices. So, the example would be like choose enough words to reach the 90%. Next is fine tuning and prompting. So prompting means giving instructions to an existing model without changing its internal parameters. So example, when you are using ChatGPT, you enter a prompt like explain Python like a teacher or explain about police academy like a police instructor. So them it's like the model stays unchanged, but you are telling it to act, and you are giving instructions for it to act like a teacher, or explain this like a police officer, or explain that like a um, professor. So these are like this is prompting. So it's like giving instructions without changing its internal parameters. So the advantages for it are like it's easy, it's cheap, and it's fast, and no training is required for the prompting method. And the disadvantages are like it has limited customization and it depends on the quality of the prompt. Next is fine tuning. So fine tuning means training an existing large language model on a smaller specialized data set. So example, a base model you can um, give like a general English model, and fine tuning you uh, so base model is a general English model, and you can fine tune it using medical documents. So then the result would be like a medical AI assistant. So the fine tuning process, it's like first you select a pre-trained model, then you prepare a data set. After that, you will train the model on the new data, and you can update the parameters, and you can deploy the customized model. So, next is model parameters. So, parameters are the are the values inside a neural network that the model learns during training. So, they represent learned patterns. So, examples are like relationships between words, language rules, concepts, knowledge patterns. So it could be various things. So, for example, if you have a small model that and you wrote, so for example, a small model, you can give like 100 million parameters. And for a large model, you can do maybe like 100 plus billion parameters. So generally, more parameters means better understanding and more capabilities, but it requires more memory and more computation. And the difference with between parameters and training data is like training data information is given to the model, whereas parameters are like what the model learns from that information. And uh, so for example, a training data is like books and classes. So you give information like the books and the classes. But for parameters, it's like the knowledge stored in the student's brain. Next is transformer architecture basics. So the transformer architecture is the foundation behind modern large language models. So Eh, it is introduced in attention is all you need. So attention is all you need. Uh, is a landmark 2017 machine learning paper that introduced the transformer architecture. A transformer architecture, a neural network design built around attention mechanisms rather than recurrent or convolutional networks, written by team of researchers including Ashish Vaswani, so it fundamentally reshaped natural language processing and became the foundation for modern uh, large language models such as GPT and many other AI systems. So, so why transformers are created? So before transformers, models used RNNs and LSTMs. So the problems for, from these are like they are like they have slow processing and they have difficulty remembering long sequences. So the transformers solve this problem using attention mechanisms. So the main components of transformer architecture. And so the main components of transformer architecture include input, embeddings, positional encoding, self-attention mechanisms, query key value, multi-head attention, feed forward neural network, and output layer. So first, input embeddings. So input embeddings are like are the embeddings. So the in this process, the text tokens are converted into numerical vectors. So, for example, if you give a text, if you write a word like a cat, so it could be converted into like numerical vectors like 0.25, comma 0.76, comma 0.12. So the amount of words that you give, cat has three letters. So those three letters can become like three numerical vectors. So these numbers represent meaning when the text tokens are converted. Next is positional encoding. So positional transformers process words simultaneously. So they need to know the word order. So this is where the positional encoding comes in. So the positional encoding adds information about the position, which means like for example, if you say like dog bites man, and so there are two sentences like dog bites man, or maybe dog man bites dog. So these are like the same words, but they have different meaning. So that's positional encoding. Next is self-attention mechanisms. So the most self-attention mechanisms, these are like the most important transformer component. So self-attention allows the model to understand relationships between words. So, for example, there is a sentence like the animal did not cross the line because it was tired. So, the model understands like it means the animal because attention connects related words. So in the sentence I tell you, so the animal did not cross the road because it was tired. So the model knows that the it means the it means animals. So it the attention mechanism it connects related words. Next is a query key value. So the self-attention uses three concepts. So the first one is query, what information I am looking for. Next is key, what information do I contain? And the last is value, what information should I provide? So together they determine the attention scores. Next is multi-head attention. So instead of one attention mechanism, so transformers use multiple attention heads. So each head learns different relationships. So example, one head learns grammar relationships, another learns meaning relationships. So they are like this is multi-head attention. So instead of one attention mechanism, so transformers they use multiple heads so that one head can learn one thing and another one can learn another thing. Next is feed forward neural network. So after attention, the information passes through neural network layers to transform and refine the information before sending it to the output layer. So next out, the last layer is the output layer. So in the output layer, the model predicts the probability of the next token. So for example, if I give the input as I drink, so the model predicts the outputs as so the predictions can be like water with a probability of 60%, coffee with a probability of 20%, and juice with a probability of 10%. So even if I write a partial sentence like I drink, the model predicts I would what I was about to write uh, using from the words and the probability of how common the words are, how common the words used in this particular sentence are. So yeah, that's it for today. And there are like some topics, and I'll continue. I'll finish them tomorrow. So yeah, that's it for today, and I'll see you again tomorrow. So yeah, bye.